Assalamu alaikum dears. In today's experiment, we will demonstrate how to determine the boiling point of ethanol. Ethanol, you know that these are alcohols, and alcohols, we use alcohol for different purposes in our daily lives, like recreational purposes, medicinal purposes, and educational purposes. So first of all is as in this experiment, we will determine the boiling point. So what is the boiling point? Boiling point is the temperature that we provide to any liquid at which that very liquid boils at sea level. When you provide temperature to any liquid and the temperature rises the kinetic energy of the molecules, it breaks the bonds between the different elements, they form that very chemical compound. The forces of attraction between these elements, when it breaks and it liquefies and it turns into vapor state or another state, that very temperature is called the boiling point. So boiling point is the temperature at which any liquid boils. As far as the alcohols are concerned, there are many alcohols, but for we will just discuss the ethanol. Uh, the higher the van der Waals forces between the ethanols, higher will be the boiling point, because if you increase the van der Waals forces, you will need higher amount of energy to provide it inside the very container, so that the van der Waals forces of attraction to break them, to overcome them, and to evaporate the liquid. So this is the chart. As you can see in this experiment, you will notice that here in this chart we have compared the alcohols with the concerned alkanes. So as you can see here, these are the alkanes, the small ball, these are the alkanes, and these are the alcohols. And on this vertical line, we have shown their boiling points. So the alkanes is they have less carbon and hydrogen bonds as compared to the alcohols. They are very much higher and significant amount of carbon hydrogen bonding. These bonds create hydrogen bonding with each other as well, which in turn increases their boiling point. So in this very experiment, you will notice that primary alcohol, secondary, tertiary, and quaternary alcohols, you will notice that how many at the boiling point is increased, it means that it has higher amount of hydroxyl groups inside that very alcohol. If the alcohol contains higher hydroxyl group, as in this case you can see, this has two hydroxyl group attached and the other has a single hydroxyl group attached. So the boiling point of this very alcohol will be less than this one because of the hydrogen, because of the higher surface area and the hydrogen bonding, as well as the van der Waals attraction. So in this experiment, we will need water and ethanol. We will, in this procedure, as we determine the melting point last day, in last experiment, we will use the burner, the beaker, the thermometer, the wire gauge, the tripod stand, and the iron stand, along with the capillary tube, in which we will pour down some of the ethanol and will heat it up. And when the temperature will rise enough, we will stir it a little bit so that temperature can evenly distribute inside the container, inside the beaker, and provide that very even temperature to the ethanol. That we tie with the capillary tube with the thermometer, and we will note down the temperature on that very thermometer, the temperature at which the ethanol boils is 78 degrees. And as we mentioned earlier, that if it is the purest form, it will have 78 degrees boiling point. It boils a lot, and its boiling point is affected by the forces which are provided by the hydroxyl groups, which increases its surface area, the hydrogen bonding, which they form with each other, the carbon hydrogen ratio, if they are in larger amount, larger bonds, large amount of bonds are there, they will increase the surface area of the alcohol. Like the primary alcohols are less as compared to the secondary alcohols, and secondary alcohols have higher boiling point than the tertiary alcohols have higher boiling point than the secondary alcohols. And today's experiment we will see it in a bit, that how alcohols boil when we provide and heat it up, and the temperature rises to 78 degrees, and then it starts boiling. So the boiling point is the equilibrium point. It is also a signature of any liquid alcohol. You know that these are liquids. It is used in many daily life activities, like we use it in medicines, we use it in recreational purposes, we use it in educational purposes, like right now we are doing. So how to identify which alcohol is this, and either it is a secondary, primary or tertiary alcohol, and we will determine this way thing the alcohol identification because of its boiling point. So its boiling point, alcohol's boiling point will lead us to tell that either the alcohol is a primary alcohol, it is secondary alcohol, or it is tertiary alcohol. This will be our today's experiment, and now let's demonstrate this so that you can perform it inside your home and write it down like this, the procedure, the chemicals that you will need in this thing. So let's demonstrate it now. Fish.